is all around us, and the Google search engine is no exception. When you search for anything, PageRank is one of the largest factors that determines the order with which web pages appear. It does so based on the importance of web pages, and that's determined by how web pages link to each other. Let's say you're searching for the meaning of life, and my pages and others pop up. An easy way to rank them would be to count the number of links each one receives. So my page has a score of 2, and so on. Not all web pages are equally important. A link from 2 should be worth more than one from 4. So I'll rescore so that my page is a total of page 2 and 4's scores. That's better, but using the system, a page can have an influence by linking everywhere. We have to weight the links based on the amount of links a page gives out. And before I go on, you can't link to yourself, that would be cheating. So let's look at my page. I've given out 3 links, so each page will receive a third of my score. If I redo the scores, it should look something like that. Now, that's a bit messy, so I'll take that, I'll bring it here, and give me a second to do something to it. Let's see, okay. Voila! This is an eigenvector problem. For those unfamiliar, I can take this, I can use it on the scores, and it'll give me the scores multiplied by some number, which happens to be 1 in this case. Now, it might seem odd that my page is ranked higher than page 2's, even though it's received the most links. This is because the quality of links matters more than the quantity of links. The World Wide Web is more complex than what I've shown you. It has problems that PageRank has to deal with that I won't get into, like dealing with link farms and pages that don't link to other pages. The biggest problem is that the World Wide Web isn't completely connected. It has all these subwebs that are about different things. A page about Batman versus Superman won't be related to, I don't know, say, bowel movements.
I agree.
Let's say that these new pages come along. This means that I have a new link matrix, which means that I have scores that look like this, but it can also give me this and that. Now, that's a big problem, because we have to have a unique score so that we can rank each page. So, we need a way to connect these subwebs. I'll do that by adding this connecting matrix together with this link matrix, and if I put it up into there, I'll get something along the lines of, give me a second, okay, this. You see, that equation up there, it can connect these subwebs and give me a unique score. So, according to math, even Batman versus Superman is related to bowel movements. G controls how accurate the scores are. If I'm not careful, I can make all the pages score the same. 0.85 is what Google uses, and there's good reasons for it. To get the scores, a computer uses something called the power method. It takes the link matrix and uses it repeatedly to grind out the scores. If we use 0.85, it will take 114 times, whereas using 0.99 takes around 1,800 runs. Searches often involve dealing with billions of web pages. So using 0.85 is not only faster, but uses less resources. Searching the web isn't a rigid process of following link from page to page. I might search for why is my hand itchy and get distracted and search for George Lucas ruined my childhood. Another way of thinking of 0.85 is that a person will teleport to unrelated pages around 5 and 6 times.
And they say pure math has no real-world application.